Welcome to part 3 of my data virtualization series. Today I'm going to talk about how to use Spring Boot to create a virtual database. These are the topics I'm going to cover today. Why Spring Boot? Recap on the use case, the Spring Boot project structure, and Openshift deployment. Remember last time I showed you how to use the data virtualization operator to create a virtual database. So why use Spring Boot now? Here are some of the reasons why. Remember, using the data virtualization operator, you create a database by defining the virtual database in DDL and also the configuration in environment variables, all in a single YAML file. Using Spring Boot, you can cleanly separate between the DDL code and the configuration. Also, Spring Boot allows you to do local testing of your virtual database outside of Openshift, because data virtualization operator only works on Openshift. Spring Boot also supports extensions such as scalar and aggregate user-defined functions, custom translators to external data sources which are not supported out of the box by data virtualization. It also allows the deployment into multiple environments. And by using Spring Boot, you can use your enterprise existing development lifecycle, including version control, CI/CD, from testing to deployment. And these are the advantages of using Spring Boot over the data virtualization operator. Now let us recap on the use case. In this use case, we are going to augment the information contained in a relational database with some real-time data. In this particular case, I have customer accounts, products, stock holdings, all contained in a relational database. What I want to do is, based on the holdings of a customer, I'm going to query a web service to get the latest share price and calculate the total worth of a particular customer. And I'm doing that using a virtual database. I'm going to control access using Red Hat single sign-on or Keycloak. These are the 4 tables contained in the relational database: customers, account, products, and holdings. And the virtual database schema or virtual database contains 3 virtual views. Stock price, which provides the real-time stock price for a stock symbol contained in the product table. Customer holdings provides a list of stocks owned and their current market value that a customer holds. Account values, it provides the current total worth of customers. And because these are sensitive information, I'm going to create access control. I will define 2 roles. First one, read role. Users having this role can access all virtual views. And also the second role is stock role. Users with this role can access only the stock price virtual view. Red Hat's build tool is Maven. And to create a Spring Boot project, I need to create a Maven pom.xml file. You can use the archetype to generate it, or you can use my pom.xml I put on Github, and you can use it as base and modify it to suit your needs. And here is the project structure. You can see there are 2 Java files. First is the application.java file, which is a must-have Java class containing the main method which set up the Spring application context. Data sources.java, which defines the external data sources we are going to access. And And in the resources directory, it contains 3 files. Application.property files, which define the parameters required for the application. And the portfolio vdb.ddl contains the virtual database definition. And I also put a key store in there, which contains the public and private key so that we can use SSL connections. This is kind of redundant in the OpenView environment because I'll be defining a secret using the deployment.yaml file, which actually contains the key store values. Now, let me show you how each of these files looks like. First one I'm going to show you is the application.java file. As I mentioned earlier, this is just a standard Spring Boot must-have file. All it does is define a main method which starts up the Spring application context. Now let us look at the data sources Java file. What it does is define the external data sources. In here, I've defined it 2. The first one is a data source, a relational data source, and the second one is a REST API. So you can see that in here, configure the properties to be starting with spring.datasource.sampledb. And in here, I haven't actually specified the configuration properties because by default is going to be because by default it's going to use Spring Tiet REST. Let's have a look at the application properties. In here, I defined quite a few properties. First of all, the name of this particular application, and then all the data source related parameters such as the JDBC URL, login username, etc., etc. And then is the VDB location, which is called portfolio-vdb.ddl, which is located in the same resources directory. And in here, you can see that I'm using the SSL configuration here, defined here, and the REST endpoint, which is this external web service, and then all these Keycloak parameters. You can see that by integrating with Keycloak, you need to have the Keycloak server URL, which is this one here, which I'll discuss in the next video. And that's it for this particular application property file. Let's look at the portfolio VDB. Again, it's using the SQL MED management for external data. In here, define all these foreign schemas and then the wrappers, and here is where I define all these 3 different views. You can have a look at it in detail in the GitHub repository. And here is how I control the access. I just select on schema portfolio to real row to the read row. By granting access to schema, that means it can this particular row can access every one of these tables or views. But for stock row, I'm only going to grant it access to the stock price view table. Instead of using the key store included in the resources directory, on Openshift, I'm going to use a secret to access it, and this is how I define a secret. And of course, you have to run a command to define the secret. You can see in here, I have logged into Openshift using user developer, and I'm on the project DV demo. So if I want to deploy it, all I need to do is run this command, and we clean -p profile OpenShift and use fabricate deploy to deploy it. So it's already deployed, so I'm not going to do it here. I have published this project on GitHub. I put a link next to the video here. You can download it and have a look and play around with the source code. Today I've covered these topics: why Spring Boot, recap on use case, Spring Boot project structure, and Openshift deployment. In the next video, I'm going to set up Red Hat single sign-on or Keycloak using the Keycloak operator. I'm going to demonstrate virtual database interaction and access control. Thank you, and stay tuned.